Dear ladies and gentlemen, welcome to the webinar with the topic Optimization in the BIM Workflow. My name is Armin, and in this seminar I would like to bring you closer to the innovation of the Autodesk Revit 22 version, as well as the associated SOFiSTiK applications in the areas of modeling, framework planning and reinforcement detailing. Lean back, relax and enjoy the next 25 minutes. As you may already see from the agenda, the focus of this session is on reinforcement detailing. We will particularly address the following points: licensing in the reinforcement detailing family, innovations in the Revit platform, and innovations in the reinforcement detailing products. You will learn new functions such as moving individual bars within a rebar distribution, grouping improvement, as well as improved bending shape recognition. Those new features not only increase the performance of the software, no, they also increase the quality and efficiency, for instance in the area of clash detection. One of the biggest innovations in version 22 is the merging of the license for the SOFiSTiK Reinforcement detailing and generation products. From now on, the products will only be available as a bundle. Subscribers to one of the two products receive the other product for free of charge. With the latest version of Revit, you can create walls of variable thicknesses. The thickness can vary over the height of the wall. For example, you can easily create retaining walls without using the technology of in-place families. To make it work, the wall type parameter variable must be set to true. In addition, you determine whether the standard wall thickness is specified on the top or bottom of the wall. You can also predefine a default angle for each wall instance. Now you can specify for each individual wall instance whether the wall should be inclined or tapered. Then three new parameters appear, with which you can override the default angles on both faces of the wall. The walls are connected cleanly each other at the various intersections, even with different exterior and interior angles. You should already know from previous versions that you can place spot slopes on each face. However, new is that the annotation labels in the new version can be rotated as desired. This can be done using the rotate function or by specifying a rotation angle. It is important that the label family is not allowed to automatically align itself to the component, because then this function is not available. In the earlier version of Revit, all bending shapes were inserted in such a way that the dimensions of the reinforcement were always extended to the maximum geometry of the host element. That makes sense in 80% of the cases. In some situations, however, you want to specify the dimensions directly without having to adjust the rebar afterwards. Example of this are U-shaped bars on an edge of the slab, for instance, 4-section shear reinforcement in girders, or additional bars on the top layer at supporting points or lines. Those bars can now be deposited with the TwoClick technology. Any reference such as reference plane, concrete cover lines and much more can be snapped. As with the conventional placement method, with the TwoClick technology, you also select the placement plane, the placement orientation and the layout rule. Activate or deactivate the tooltip directly at your mouse pointer. Then place a rectangle with the 2 points. The bending shape is again aligned to the maximum in this rectangle. You can use the space bar to align the bending shape differently in its bending plane at any time. It works similarly for supplemental bars on supporting points or line. In this case, I've prepared reference planes that should define the dimensions of the rebars. This can now be used to precisely define the length of the supplementals. The horizontal and vertical option help us to install the bar in the right direction. In the case of different orientation of slab edges, you can use the arrow up key to align the rebar layout with the corresponding edges. In this way, you can efficiently generate the reinforcement for certain sub-areas. As already mentioned, reinforcement labels can also be rotated as required with the new version, so that the labels can be aligned with the reinforcement elements. With version 2022, a new type parameter for rebar has been added to the database, the model rebar diameter, also known as the real diameter. This is used to represent the geometry of any rebar element. For the calculation of the hook length, if set to automatic, the bar diameter, also known as the nominal diameter, will be used. By default, the model bar diameter is set equal to the bar diameter. However, this can be adjusted by the user. In this way, you can ensure that reinforcements are displayed in the model with the real diameter, which correspond to the diameter including the rebar ribs. This gives you a more realistic check of rebar clashes, which is particularly important in the case of very highly reinforced components. The bending shape are also shown with the real diameter. On the other hand, labels and bending schedules show the nominal diameter, as this is decisive for fabrication. In this example, we can see a bar with a nominal diameter of 16 and 25 respectively. They have a real diameter of 80.5 and 28.8 millimeters. The reinforcements are shown with the real diameter in the elevation view and in the section view as well. The hook length, which is defined as 5ds in the standard, is still calculated based on the nominal diameter. This results in a hook length of 80 mm for the reinforcement with a nominal diameter of 16. However, the calculation of the rebar weight remains unchanged. Also here, the nominal diameter will be used. In this context, I would also like to point out a new feature in the labeling. In the current version, all labeling elements have the option to activate multiple leader lines. For instance, you can tag several instances with one label element at the same time. The prerequisite for this is that the properties of those objects are the same, otherwise only the value varies is displayed. However, if this is the case, the number of objects in the label is also represented. This must be explicitly built in the label family. Cause we always create the perfect geometry when modeling the digital copy, we always come to constellations, especially with the reinforcement, where we get a clash, which in practice doesn't play a role. We would also like to avoid this on the digital model. In this example, I show you a clash with a beam opening and some bars coming up from the column below. In Revit 22, you now have the option to edit the bar distribution and modify individual bars. It's not about changing the dimension of the bending shape. However, you have the option of influencing the location of the bars or even removing individual bars from the layout. The layout rule, such as the spacing, are retained. The number of bars is only adjusted accordingly when removing a bar. Simply move any bar in the edit mode with the move command or use the temporary dimension to bring the bar into the correct position. In addition, you can display removed bars in the edit mode and then show them again or hide additional members. You don't even have to switch to edit mode if you only want to edit certain bars. You can do this directly by using the Tab key to select those individual bars and edit or hide them accordingly. You can also reset individual bars to their original location at any time. Resetting is also possible for the entire rebar layout. The grouping technology in the SOFiSTiK Reinforcement application have been completely revised. This results in an improvement of quality, stability and performance, as well as extended functionality. The technology of the reinforcement container has been eliminated and is being replaced by the new freeform rebar. Using the example of stretch trim two lines, we can see that with version 22, a reinforcement container is no longer created in Revit, but a standard element consisting of freeform rebars. This means that you are no longer so restricted in any post-processing. You can add hooks to those elements at any time or change the diameter, for instance, which was not possible with the old rebar container. The placement of rebar coupler is now also possible with the new version. We have therefore removed the SOFiSTiK coupler parameters because you can now do everything with the native Revit couplers. This allows you to manage the couplers more easily and consistently. This also opens new possibilities for labeling. For the hide and tag command, we no longer need a detail element that we have to laboriously hang on the rebar elements. That increases the performance enormously. You can now use the native Revit functions for hiding individual bars of the layout and hide any number of rebars or isolate them accordingly. This ensures that your drawings are easy to read. And because I personally like the new feature rotating labels, I want to show it again here when it's used on the rebar elements. Thanks to the new labeling technology for hide and tag, the distribution line and the label element are now better connected. This improves the efficiency when arranging the individual annotations. The new grouping technology also offers us further options. For example, we can better collect rebar layouts with more parts and tag them more uniformly. The associated labeling elements have also been adapted. You now have the options of displaying the number and the associated layout distance for each part of the layout, as well as the bar mark number and diameter for entire layout. Even if you move the label thereafter, it behaves as it were one single object and is therefore very easy to adapt. You can also simply hide the individual bars if you do not want their representation on the sheet. The SOFiSTiK application for reinforcement generates a number of additional parameters that are very important for the management of reinforcement in complex projects. New parameters are added in each version, which can be very confusing for a user. In the latest version of SOFiSTiK application, we have given a lot of thoughts to those parameters and implemented new improvements. Reinforcements have a layout rule as standard, or to put it in another way, reinforcements are rarely placed as single bars. Normally you use a layout with spacing and number or similar. When converting to freeform elements, which we have to do for certain operations, such as freezing, this layout rule is lost in Revit. In the new version, we have integrated new SOFiSTiK parameters for both the layout rule and the according rebar spacing, which keeps the information stored in the element. In this way, we ensure that, for example, the spacing information is still displayed even after freezing. Unfortunately, this was not yet possible in the earlier versions. With the SOFiSTiK parameters A, B, C, and D, which assign the leg length of the individual bars according to national standards and sort them correctly, we have decided not to display parameters that are no longer used. The straight rebar shape no longer has several parameters for leg lengths, but only one. This makes it easier to get an overview of the instance parameters for the rebars. Up to now, it was not possible to evaluate the total length in Revit schedules for running length rebars. For this purpose, a new parameter has been added to SOFiSTiK Reinforcement Detailing, which calculates this value for each individual bar mark and allows it to be evaluated as required in Revit schedules. The parameter SOFiSTiK Text Custom gives us the possibility to collect any parameter values quickly and efficiently. Simply put the desired parameters together in curved brackets in the Settings dialog. Use separators if needed. You can also easily transfer those values to the bending schedule. This new technology works in a similar way for the bar mark number. A prefix and suffix have always been possible, but now this can refer to other parameters as well. In my example, I used the bending shape code as a prefix for the mark numbering. You can add any additional information to the mark numbers. Setting the marks once again changes the mark number, which are immediately visible on the sheet, and of course they are also reported in the bending schedule. Each standard defines its own standard bending shapes. These are clearly specified in the respective national codes with regard to their parameter information. However, if a non-standard bending shape is used, the bar becomes the code 99 as shape code. This shape code stands at least in the ISO standard for non-standard shapes. Those 99 bars are all treated all the same by the software, and our general bending shape sketch is generated for them in real time by the program. This has two major disadvantages. The generation is complex and performance intensive, and the sketches can become illegible in certain situations. That is why we have improved the bending shape recognition. The user now has the option of defining his own standard bending shape codes and can then assign the corresponding bending shape family to them. In this example, I've created a simple bar with one angle, but it has an acute angle. This bending shape is not defined as standard, which is why our software currently set the bending shape code 99 for it. The bending shape detail is generated in real time and is given the global unique ID of the element in the name so that remains unique for this bending shape detail family. We also see that no bend diameters is displayed as for bending shape 15. With the new version, we give the user the possibility to define his own bending shape rules for the recognition. This can be done in special text files in JSON format. In this example, I simply copied a file and renamed it so that the bending shape 17 should be recognized. As a basis, I took the bending form 15, which only differs from the new bending form in terms of the angle. I've defined a rule that the angle must be between 90 and 150 degrees in this file. If we now remark all the bars, the bending shape recognition will take this file into account and recognize the bar as bending shape 17. If I then place a bending shape detail, the shape family assigned by me in the JSON file will be used. In this way, you can better define and manage your own standard and ensure that your requirements are better adhered to. For example, we see that the bend diameter symbol and also the offset of the endpoint from the second leg on this bar now appears. For sheet-related work and calling up the bending schedule being on a sheet, the bending schedule is generated from precisely this sheet. This can be time-consuming with several sheets, which is why the new version gives you the option of executing the bending schedule of several sheets at once. It is important that you are not in a view that is assigned to any rebar drawing. You can now choose from all the sheets and selectively create several schedules out of it at once. Several Word documents were now generated, which you can print or convert into a PDF. This could also be tedious, which is why we have added a new option, which in addition to the Word document creates a PDF and an ABS file at the same time. Those data were stored in the assigned folder. This saves a lot of time when creating multiple bending schedules. For those who do not want the bending schedule to be external but prefer to use it directly with schedules into Revit, we have also incorporated an additional improvement in the new release. We deliver predefined Revit schedules in our content pack, which you can use as bending schedules. These are added to the project when the content pack is loaded. All that remains to be done is to define filters so that, for example, we get different schedules for individual sheets. Thereafter, you can filter or sort the schedules as you like. At the very end, I will show up a small feature that only has something to do with the bending schedules. It's about the linear spacers. Those are usually placed on the plan as symbols and are interpreted by our application. However, if there are several families of symbols in the project, it is often difficult to find the right symbol for the spacer. That is why we have built in a separate command for this. This now only shows the spacer families and the tedious search is no longer necessary. Conclusion. The new version of Revit 2022 and the SOFiSTiK Reinforcement applications offers you not only more stability and performance improvements, but also a large number of features that not only give you more flexibility in modeling and analyzing data, but also increase your design quality and save time in certain operations. So, switch to the current version as soon as possible to increase your efficiency. So, we have come to the end of the webinar. I hope you have all taken something with you and you are still looking forward to the new version. If you have any question, we will be happy to answer them after the session. Otherwise, please feel free to contact us at any time afterwards. Thank you all for your attention and enjoy the following sessions.